close enough. I can just get away with that. Actually, let's just do that. As ridiculous as this is. And if I can get the midpoint now, there isn't a midpoint though. There's no such thing as a midpoint for projected. I can estimate the radius of that. Stating 28.5. I hate doing hand coded. Very consistent though. 6. Gross. times. And this one I've listened to too many times as well. Okay. is. Okay. So 54. Doesn't quite match up with the model. Are silly. Oh, pull direction. Okay, there. Pull direction. 20. Aha. Gotcha. I wish I could chain. let's just take one final pass just to be sure. Yeah, pretty sure. I'm very, very careful. Quickly show this is what I've been doing and working on. So I used that reference, and that was pretty much a warm-up for doing the canopy. So after a few iterations, I finally got, I think this is the prime one that fits right now. This is the prime volume, but you can see I've printed off a few of them. Yesterday was 3D printer nightmare day because the 3D printer had clogged nozzle and it had SD card issues, and I hate PETG. PETG is of the devil. But yesterday, lots and lots of work, but I got a few different ways, and this is fitting pretty comfy now to the back pocket. So, let's do this. Okay, let's do this. Well, okay, final measurements. What is it? Let me see. Okay, so that one is from the back. You know, why don't we just make a new 3D sketch for measurement? Close enough. 45.6, which would go to 90, 1.2. 1.2-ish. And what was it I just measured? Yeah, it was 92. That's what I got here across. Just a very quick and dirty way of measuring. So let's try that again. So what if I did it like right here? What did I get? So approximately just below the 10. So measure that. are you now? Shut up. Come on. Alright, there we go. This is totally organic. Totally just back to that. Just the maximum point there. Roughly corresponds to Wait a second, I was measuring off of the wrong 50. Yeah, 55. It still is off. So right here, which is 60-ish. Yeah, okay, so I'm very close. To about 140-ish down. So 140 down. Let's see. 140 down. We got about 84, was it? So let's see the other line. Since when do I not have a... Oh dear. You're trying to do the... Okay, I didn't have it visible, that's fine. Should save that again. Oh dear, I don't want to have that. Something to cover up the hotkeys. So they can stay still. Don't options, high. Okay. Yes, I do. This is gonna take all day, even in base mode, I know it. I suppose that's reasonable. It's probably the best direction. I love having a big 3D printer. Oh, I love that machine. Okay. If I can get right. I'm gonna pick 9060. Let's get 40. 60, 40. We can go back to 60. Just gonna sort of make something up. Okay, so I'll put this at about 4 hours 20 minutes. Let's see how good my guess is. 4 hours and 20 minutes for phase mode. Oh, 2 hours. With exactly 10 meters of filament, 30 grams. And that is going to be basically the outer wall of the skirt. What is that? I wish it was showing me. I guess that's 40. Hey, what you doing? Why'd you... Did I just forget how these work? Sweet. It is one watertight surface that doesn't have islanding. Oh, I take that back. It's got islanding. Glass it. Is there any way I can glass that? That's unfortunate right there. Otherwise... If it survives that... Let's try this out. Let's do it. The card is loaded. So, 2 hours is fair. And will this actually stay together as a vase? Vases usually fail when you have flat sections, so this will probably ripple. This area is going to ripple, but this will probably be fine. It's really interesting why vases... Yeah, this is going to ripple and crinkle. But otherwise... just for reference. Should I use PETG? I'm trying to get rid of that stupid roll, but I have only had poor experience with it. But for vase mode, I think I can get away with PETG. So let's go with the 240. Oh, and let's go to display only. I'm cutting up a whole bunch of this. So this is what I was looking at. automatically changed to travel trip. I thought that was already at 30 and that was at 5,000. It's changed to that. Why did it do that? Easy hops, for brim. For... We're dealing with PTG. Let's go with about 6. Just because PTG is a complete disaster. Wait, and this is the shot of survival. So I know that's going to fail. You know that's going to fail, Steve. It's going to fail. Let's think this through. What am I going to do? Do I even want to just print pieces of this? Like, do I want to just print the top part to test if that fits? You know, I think I'll do that before I commit to the entire thing. Let's submerge it. We are only going to print off... that should do -180. How does that go? So I'll give the PTG, I can relax that back to 4. It's a good demo, it's 20 minutes. I'll even let it go down to 40. I know it wants to do. Stop it. I didn't want to touch that. There's no way for me to abort. I can't abort because I'm grabbing it. Let's not. There again. Okay, so that will give me a good estimate for the front, and I'll be able to make any adjustments. Which should fit. The thing is it doesn't have the This is ridiculous since I don't have anyone watching, but watching this, I'll be right back. So let's just leave that there. Okay. speed. Travel speed got pushed to 40. Whoops. Oh well. Hey, what's this snazzy song? I like this one. Okay, other things to do today. Let's finally figure this thing out. So, change tool sets. Let's go to this. Just verify this is visible on the camera, right? I guess I'll tilt the camera up a little bit. Now, today we might also finish the Toothless 2 model. But I modeled the microphone, so this is the microphone model. It doesn't have to be very high resolution, it just has to be close enough. So that's the microphone, and that's going to be mounted in the rear hatch. I decided to rear hatch this one there. The whole point of modeling the rear hatch is now I can model this specifically for antennas. I can have antennas being mounted on this, but check with the 3 camera. I really should have just printed the whole thing instead of just the nose piece, nose section, but oh well. Alright. Let's open the Toothless 2. So I do need to finish this thing. And then also, really easy low-hanging fruits today. Let's go for the first guy, CR. What is the appropriate practices for that? Box. I'm gonna go east, north, up. So east, north, up, coordinates. And I'm gonna put the front as up. Really quite rudimentary, you don't have to. This is my easy and quick way of putting this now with the stupid calipers. Stupid calipers that click on the battery even when they are off. The battery's only. I so despise this set of calipers. By the way, this song I'm totally not a fan of the cover, but I shall see this. Verify that everything is still working correctly for the stream. Okay. You know, I could go to the FR Sky website to get this. I'm not going to go there. Okay. This is 26.8. Okay. Get that across. Yeah, 27. It wants to be 27. It really wants to be 27 millimeter wide. Nice. So let's just go for 27. And that is okay. that doesn't happen to be an inch per orange. I like to say is the top. And then does that make that? This needs to be the front. Okay, and then that should always be home. And let's save this. I'll explicitly exit and then save. And you are the FR Sky and FPV printing in main library where I shove everything. FR Sky exit. This is sized the way it is. It's 14.37 verified. Gosh, you did it again. Okay, 14.4. Okay, and yeah, I'll have the floor be there. And I'm just gonna do a traditional. It's even worse. Looks like going a bit. This is 5. Let's do this. Away. Oh, I didn't want that. No. It's good. No. Yeah. Okay. Let's try. So 25.4, or rather 2.54. Yeah, I have to be careful with this wrong button. Times 2.5. Really? What? 2.54 millimeters times 0.5. I'm going to fax that way. What? connected. Why? Really constrained. Okay, whatever. I need to make the complete pocket. So I'm gonna have to make a guess. First of all, let's take advantage of symmetry where I can. I'm just gonna black mill, but I'm not, so I'm gonna skip this black mill style. It seems a little bit too generous. It can't be. It can't be 2.8 or 0.7. Right, this is 14. 4.4. Can't be right. And then this is pocket. This is more detailed than it deserves. And as usual, the stupid guys. As usual, fine, whatever, that's about 6. Yeah, but you're about 6. By the way, I didn't want you to include that geometry because that's going to be explicitly pattern later. That really. Actually, that's about right. 2 millimeters. 1 millimeter is actually a little bit more fair. Alright, then let's take both those surfaces and I can put that about 0.4 millimeters. Yeah. And I mean, 10 years ago I would have taken pictures of this and I would have put pictures on the face and surface of it, but you know what? Nah. It's just select all that. It's not worth going through all that effort. Things that are smooth. I want smooth gray. It's going to be more of a smooth black. Yeah, that's about right. And let's go. I could have done this with one sketch. If I just did a side sketch and extruded through, I would have had to have 2. Oh well. I'm not in the contest with anyone to do all these kind of sketches. I said I was going to kill this black mill song, and I was going to do. No, what is next one? And I should probably even put it away. But the problem is, there's no point in putting it. I might use this later. If I ever do need to use this later, then I'll put it away. But for now, I'm not even going to use the bottom of this. What was important though is I need to demonstrate to myself that I have. I'm going to go to prior to the fillets, so I'm going to go here. I do need to make sure I articulate that there are also these. Yeah, there we go. Other, and I would put them in about a mil. 0. These little chords here about 1.2 is fair. Okay, and then they're all set. But that's an easy way to grab that. Babbling. Okay, this is getting shocked. It's more like 6, even though it thinks it's 48 mils. What is a caliper if it can't keep good measures? Really, just a non-battery powered caliper would probably be perfect in my life right now, since this battery powered one is just going to estimate you at about 11. Now let me see there. I'm just going to extrude those out about as far as I would declare these as being happy. About 4 out. And they need to be black. So I might make them a slightly different kind of black. Let's try the black here. Sure, that's fine. And let's take you to the end. As a way to articulate that there's a hole on top. Let's it's more detail than it deserves, but okay, let's keep the hole. It's about 3. Oh my gosh, you kill. Okay, let's try that again. 63, you are really losing it. Come on. I don't want to be mad today. Come on. There we go. So 10. 10. there. That's it. That is as much time as I should put into this. Okay. Well, technically I have to model the antennas now. Because the whole point of modeling the rear hatch was for the following. We're going to make a new assembly. Let's create. By the way, I'll bet the printer's down. Let's go check that out. Oh dear. Let's close anything that I don't want to have lost in a crash. This is a weird song. So let's call you. No, not very creative. To do two lights. I don't like this default lighting situation. There's probably some features of Autodesk I've never used in 10 years that I really should. So if I say pull in this, I could use this to be like Boolean subtraction, right? Except it's not a very nice work surface. Yeah, there's probably features I've never used that would probably be amazing. Solid by cube seams. So yeah, this is one route I could do, is I could try doing derive operations inside the base part. But what I'm going to do is in the assembly, I'm going to just place those parts. So here's the receiver. Okay, and then I'm also also going to have the microphone limit back here too. Okay, and actually, with the microphone, this is over-engineered. This is way over-engineered, and I don't care. So I basically have to go in here and what the heck am I doing? What the heck am I doing here? I have to make something that's as lightweight as possible. So do I need to shell this? Now I'm getting that anxiety or fatigue again that I had on either Monday or Tuesday of this week. I'm getting modeling fatigue. I can get as far as this, but then I can quickly switch gears to something else. Yeah, at least I have this ready to go. And, well, not quite yet. There's one more thing. Okay, modeling the antennas for this thing. I'm half tempted just to tear the antennas out of these. I think these are microwave fused or radio fused. I don't know what that's called where you use a microwave to actually weld. That's what it is. It's radio welded, microwave welded plastic. So am I really going to use a Dremel or a hobby knife to put along this and try to extract the antennas that are in there? It's hard to even see, like going up to the light and trying to look through it. Very opaque, but I know that there's blade antennas in there, or just simple quarter wave, half-wave dipoles formed out of PCBs. And so I have those sticking out of the vehicle, out of the rear hatch in a V formation. Yeah, getting fatigue. Okay, let's go check on the 3D printer and get that off. Wow. Last summer comes up with a nice con. This song is way overused in various video blogs and racing drones. Oops. I'm skipping it. This is very hot, but here it is hot off the printer. And if I can cool this down sufficiently fast, let's pop this off. Dare I pop it off now while it is still molten at the plastic printer? I can get away with it. Yes, I can. Okay, build plate. Back. Okay, getting tired of Ryan Parrish. Except Sunshine is a good one. No, Sunshine is really just a good one. This one is which actually is 3 more in the list. Let's do it. Okay, so where was I? Let's compare. This looks bigger. As anticipated, there's slight warping, but it didn't get a chance to have that surface exposed to it. So it's not a... You can tell there's some... all that matters is if it fits, so let's get out to the body. It might make it. Trees coming up. Hey, not bad. Wow. I mean, yeah, there's a slight gap there, but wow. Wow. Okay. Ah. I really pulled it off. The slight that I could. This is probably the most complicated organic shape I've ever reverse engineered. And I'm glad to have shared this. Of course, there's the. I don't know if that's showing up in the video very well. Come on, camera, capture the. I don't know what to call it. Beveling. Chevroning, and you have, that's a very subtle feature that I'm going to have to add to the model, or do I? Oh yeah, it has to be properly seated. The ultimate things that really seat it though are these back rails, if I call them, or rests. That's all that matters, is that these rests match, and then that it fits into the cusps there. And then it has, I'm getting really ridiculous here. Yeah, this is not a very good camera position. Point being is, this is actually working. Let's authorize the full print. I'm gonna go for the full thing. If the lip matches, let me just put that again, just to be sure. Not. Really does very closely match. Very close. Now, how about, thankfully I can see through. I could actually even try feeling to see how close. Let's do that. Let's just let's cut. I can't really show a lot of this on video. I'm just gonna have to leave it resting on here while I talk about it inside. That's strange. That never did. Done. authorize the full thing. Okay. And I'm going to use the PLA roll. Even though I hate PETG with a vengeance, I want to get rid of that roll as fast as I can with things like this. Whatever. Let's do it for 0. Now we want to put the travel speed back to... travel speed can go back to 120-ish. It actually takes it off. That's a little concerning. Travel speed was always as fast as I wanted to go. Why is it? What is it calculating it off of? It must be forcing it off of all speed. Faster than that, but I just want to force the spiralized to be 40 kilometers a second. So 2 hours on the dot, so 10 meters of kilometers. So that's going to be Alrighty, I think it can be trusted. What did I miss? Okay, now what? Now let's need to finish this. I'm considering just stopping the stream at this point. It's 2 hours. And, yeah, I think 2 hours is fair. Or let's think this through. So yeah, open things I need to solve. Things I need to do. Okay, so again, I had, there it is. My, this the other day, today I was fine. This is what I got done yesterday. So, no, didn't have that happen. Model, so that's what I'm doing right now. Printing it. Okay. Testing the cover and the wings. I did that. stuff is Canopy 3D modeling, which I'm doing, toothless tube camera model, and then the servo pan tilt design. Okay. So, yeah, critical path. What do I need to do? Cover the wings. Yes. Video board. For me to get a flying airplane, I have to get the video board done. I keep putting that off, or I keep crashing. So here's the plan. I'm just going to mute the music. So instead of muting, I need to pause the music. There we go. So I've taken the Hobby King Bucks and I've taken off the covering, and what I'm planning on doing is actually desoldering the pins too. If I'm not that desperate to save weight, but I don't want to solder directly to pins. What I'm gonna do, I need a let's get this out. I'm for sure I had other proto boards running around. So I got these little boards. I just need some kind of a prototyping situation here. I fit these on here. This was originally going to be the video distribution amplifier proto board for me to build that up as a one-off handcrafted item. But yeah, these guys do not quite, unless I desolder those, and then they don't quite line up to the grid. Almost lines up to the grid. Just about. They probably designed that so you couldn't accidentally get a servo to cross-plug across those. Yeah. I think what I was stuck on here was I needed 5 volts. 5 volts for the microphone. 5 volts is going to this guy. Okay. What I need to do is I need to get rid of these. These were implicit. I need to actually expand that. Well, actually, let's at least save that one there. So VideoMux Select is going to consist of 3 lines coming from the receiver. Actually, yeah, I can articulate it this way. I can do a bus connection, or rather, wire to bus entry is what I want. Oh, cool. I can do that, and that, and that. Okay. And then, sweet. That's what I want. And then, right there. So what that is it's going to have the ground, and it's going to have plus 5 volts, which, do I have a plus 5 volt anywhere? I do. There we go. I believe it's the same. Plus 5 volts. Is that coming from the receiver? I don't know. VideoMux selection should be coming directly from the receiver. I don't want to give the Pixhawk more signals than I than it should be getting. But then again, I don't want to have so many wires going through the wire tunnel to the receiver. So I have to decide which wires are going back to the receiver in the wire tunnel. Like, for example, let's quickly articulate this, and let's do this in Notepad. So, sorry, Franklin, I'll get back to your writing later. Here's receiver connections, and really a spreadsheet is what this should be. So, okay. Variant. What am I trying to do? This is a variant A, B, and C. Yeah, I want to redo this. So I'm going to do set notation. So, let's do this. Whatever, just type something in there to get it to stop doing that silly tab thing. Big option, or let's just say option 1, option 2. Okay, so really, connections, okay. So receiver in the minimal case is only SBUS, that's it. And this is going to get the rudder servo, and video select, and what were the other optional things? Yeah, the, what do I call it in the, I call it RC switch bus B. So video max select, let's just do, what do I call you? Video max select, whatever, video select. I'm not going to have a one-to-one between variable names here. So bus A, bus B. So ultimately, the S bus carries all 16 channels, and I'll just have the Pixhawk replaying those channels. But if the Pixhawk goes down, then kiss all of this goodbye. The other, so option 2 was S bus. Technically, I could put in the PPM single, but S bus is superior. So do S bus and rudder, and that's it. There's a few others. Oh, there's lots of combinations. I could just do S bus and then switch bus A, bus B. Technically, switch bus C. There's actually a C bus. I need to put down some definitions. C. So let's put in some definitions. Definitions. A. And since I'm lazy, let's just duplicate a few times. Switch bus B, and C was the companion computer. It actually makes sense. Which is the RS. Okay. Switch bus B in my mind is the B is in backup, but I'm really not that married to the bad acronyms or forced acronyms. I just think of B as the non-essential or long-range bus. Which is the 1G2 VTX. I'll do that with that, and lights. Yeah. Okay, so it's 5G8 VTX cameras max. Okay, and then I really should save this document. So what I had come up with, the current debate, current issues. So power option 1. Okay. Should I say no switch bus B or just okay? Okay, yes. I can't spell permanent. Permanent or permanent? Permanent. Active. No. Okay. Yeah. So I definitely am going to have the 1.2 gigahertz transmitter and the lights being able to be turned on and off. Okay. Option 2, which is the one I'm currently doing. Yeah, I'm mixing things up now because definitions. Let's actually do this. I'm going to wrap the definitions under the option level. Okay, I like this better. This is a better way to format it. Option 2. I don't think hardwired is the appropriate name. By the way, my spidey sense is going off with the 3D printer. Let's make sure it's not dying. I hope it hasn't made a heat rat's nest. It's holding on for dear life, but you know what? I'm gonna have to add supports. And supports with vase mode. Last time I checked or tried that out, I think gets a little wonky. Let's make sure it's about 70, as sharp as I dare. Oh, I didn't want everywhere though. Don't do everywhere. I only want touching build plate. I am curious though. What did it think about? It thinks it has to do that. Okay, prepare. And I'm gonna have to remove by hand. Hopefully I don't have to make a second one, but if I do, okay. So yeah, vase mode. I wish I could force geometry to connect, so that way it doesn't interrupt it and do islanding. Oh, and I'm doing it again. Shut up. Stop it. I don't want to touch you. I don't want to... I'm too used to too many different CAD tools that use rotation with different mouse buttons. Why can't the community just agree on a single method for being able to rotate and move and pan? Some tools you pan with middle mouse buttons, other you pan with left or right mouse drag. Okay. Anyhow, I will study that later. But where was I? So hardwired bus B number 1. I'm actually flipping but whatever. And duplicate, and now I can just delete you, and delete you, and B2, and keep out video select. And technically I could just keep bus 1 as lights and the VTX. I don't have to use both RC switches. If I can just get away with using a single one, I don't have to have all the extra complexity. I think I'm going to do option 2, the essential bus. And then for the lights and the 1.2 gigahertz transmitter, how am I going to do that? You know, if I can make it so I can adjust that in the future, if I do want to have the lights on their own separate channel, that would be awesome. But you know what I'm going to do? I think I'm going to consolidate. I'm going to, let's call this option 3 actually. And then let's clone. Oh, of course you have to grab all of the lines and then duplicate. So, yeah, what was that? Why was there an extra tab? Let's get rid of that, even though it's invisible. So let's do the in-between option, which is to completely remove. We're just going to say bus A. Bus A, which is non-switched. Switch bus B, and there will be no switch. Oh, wait. So there are only 2 switched connections here, and video's 3. Whereas you would have had 4. Count it, 4 different switches. I mean, that's already a lot of things to keep track of. It's approaching the complexity of a full-scale aircraft now. Yeah, the essential bus. Why do we want to have the essential bus not be switched? Why would we want to do that? First of all, the reason why you'd want to switch a bus is mainly because of heating issues. For the 1.2 gigahertz transmitter, that thing is going to get so hot that handling on the ground without airflow is going to cause it to overheat. And there is no sensing ability on that for it to detect overheat and for it to shut itself off. It's a flight critical video part, so it shouldn't have the ability to turn itself off. Not autonomically. It has to be something that I, as a pilot in command, can do with the equivalent of pulling an electronic circuit breaker, electronic fuse box. So that is, I wish I had current sensing capability in the RC switches. What I will have is I actually do have master current measurement here, and if I am gliding around, why would I want to measure current anyway? I don't know. Anyhow, it is regrettable I have to use 2 video muxes, and I'm going to do this wonky camera path. Basically, no one camera is going to split between 2 different outputs by arranging it with. This is probably a little difficult to read. What it means is that the 1.2 gigahertz transmitter is being fed to the primary camera when the video mux select is on 1100 microseconds. And apparently it doesn't have a boot up default. Apparently on default it doesn't default to channel 1. I'm not entirely sure. I was measuring it, it didn't seem to do that. And then when you feed it middle, or 1500 microseconds, the primary camera, I mean not primary camera, that means the tail camera is fed to the 1.2 gigahertz transmitter and nothing is monitoring the primary camera. And then on 1900 seconds, you would have the primary camera is routed to 5.8 gigahertz. And the Raspberry Pi console is only monitored on the middle channel. Wait a second, am I doing that right? Now I have no idea what I'm doing. Raspberry Pi really isn't monitored, except on, doesn't it? No, I'm doing this right. Yeah, Raspberry Pi console. Yeah, each of these has for 3 cameras and 3 selections and 2 video transmitters. That means that for each camera there's 1 slot that is where that camera is not implemented. So there's blank spot here, blank spot here, blank spot here. It would make more sense if I just made rectangles or something. Anyhow, this was the easiest way for me to articulate what the switching scheme is, and that's captured here. So video out for the tail. It gets. Wait, what? Did I follow that incorrectly? Video out. That's the camera. Video in. Okay, there we go. So this mux gets a slightly different flavor from what this mux is putting out. So this one, depending on how I've wired them up and which port they're plugging into, video 1, 2, or 3, 1, 2, or 3, that's where this comes from. Where I'm assuming video 1 is the selection for 1100 microseconds. So, where was I? Anyway, I hear... Okay. Wait, could I have taken the trash out today all along? I noticed all of the neighbors' trash cans along the street already had their lids flipped up, and it looked like it had already come by. But now, dang, oh well. Let's go check the 3D printer. Spidey sense is going. Okay, so printer has survived. I'm just gonna have to clip out some of the bad resting reference geometry. Okay, I'm glad in terms of survival, I'm glad I survived the 2-hour mark. So I'm finally back on the saddle again. I get to the funk of where I get into sort of a rut where I'm like, oh great, I'm getting fatigue. I don't want to deal with it. Okay. So, video out. So that's explaining why I have video 2 and video 3, video 2, video 1, video 1, video 3. That's why they get the different references. And it means that, yeah, the camera might momentarily, across these transitions, with dissimilarities between the 2 muxes, one might switch while another one is still feeding, or rather pulling. But it's not a big deal. It shouldn't be a big deal. It just means no more video distribution amplifier. I'm so sorry, bud. You are being deleted because I can't generate -5 volts on this board, and I can't figure out how to level shift that correctly. It's not worth the trouble. It's so tempting, though. If I could find some elegant solution for level shifting the video from 0 to 1 volt referenced to this ground to being a reference of 6 to 7 volts with reference to a 6 volt virtual ground. And then I would have -6 and +6 volts, but it's such a messy, screwed up, yeah, a rail-to-rail amplifier, rail-to-rail amp would work, except they don't make dip versions of that. So there's lots of surface mount rail-to-rails that would have done just fine for the bandwidth and speed requirements, but there was no through-hole option, and for me making a one-off handcrafted prototype, I didn't want to have to deal with surface mount and figuring out how to get surface mount SOIC 8 pin to go to PDIP 0.1 inch grid. And just looking over, yeah, this is not actually good. Okay, so video max select goes to 5 volts. So that's 5 volts is the important bit, because I have to feed 5 volts has to go to the microphone, which requires 5 volts. And I should probably articulate that. So let's change up VDD, and it was, this is a little bit on the covering. So covering, and then the camera's actually in the way. I can't see very clearly. What was that? Content us. New stuff. Laminating films. Where did I put the Adafruit? There we go. So 2v7 to 5v5. Let's put that up there. 2v7 to 5v5. And save. So I have to have 5 volts, and that's where it's going to come from, is from the receiver for our audio. So, we're just about to have this nailed down then. 5 volts here. Minimum OSD has to live somewhere in close proximity to this. The minimum OSD is going to use regular connections, direct patch. So that means at least one of the muxes has to have on its input unclipped. No. Well, yeah, this right here. See this splice, the Y splice there? So something has to happen where I have 2 video muxes mounted there on the board. What if I could take hookup wire or speaker wire, and I could directly solder from one pin line to another pin line on another video mux board. And then I'm still trying to figure out, this is going to be mounted on a piece of FR4 or something, and I'm just going to hot glue them directly on there, and then that's going to be where I'm going to directly hook up wires across, and then I'm going to heat shrink the whole thing. And then because it's containing video, I would want to shield the entire bundle as well. So I'd want to wrap it with some kind of a shielding substrate or film, and then I'd have to connect that shield, and I'd have to be fairly caged. So this is, oh, what a mess. Okay. Can you get away without shielding the entire bundle? Yes. Yes, I can. By the way, let's just quickly switch gears because I love switching back and forth. Yeah, this guy, no, let's not worry about that. I have to wear so many different hats. Where was I? Just as a quick aside, this is an utterly futile exercise in terms of future-proofing. There's, in terms of UAV technology in the future for recreational long-range sailplanes like what I'm making, how useful is that in industry or otherwise? Because technically, during the Raspberry Pi, with the video forwarding ability from the Raspberry Pi camera, that's a little bit more valuable in the modern engineering economy, I suppose, than dealing with analog video boards and minimum OSD, which is 7 years old, and I'm going to be trying to code that. Yeah, I really do need to well, yeah, the Raspberry Pi on board is going to be nice, and that's really what this whole thing is. It's a platform for the Raspberry Pi companion computer for me to be able to do cool stuff with the Sailplane while also enjoying thermaling as well. Having a very, very efficient and slick airframe is very useful. What was I going to do? Oh yeah, I guess for grounding, I grounded that outboard. I really should have done both. I did do that there. I did that. Okay. You see, what was this going to go feed? Because I already have servos being fed with 5 volts. And that is also going to power the receiver. Actually, the receiver is going to be powered by the Pixhawk S-Bus, right? I actually don't know. Let's find out right now. Okay. You know what I could do? I could just quickly look up the reference documentation for the first generation Pixhawk, but digging around for a PDF for the next 2 minutes versus let's just immediately determine I'm really quite certain that the entire rail across the Pixhawk is going to be 5 volts. And I think the Pixhawk is able to feed off of the 5-volt rail, but it's not its primary power source. This is still a very well-designed piece of equipment, even 7 years later, when compared to modern flight controllers like the Matex 722. Matex 722 does not have, say, the properly buffered servo output pins or the dual flight computers. This thing has an STM32F100 as one of, or the output driver, and then it has the STM32F4 something, maybe 427 as its main. But yeah, there we go. So it says RC, which is going to be PWM, or PPM to be exact. Hey, check that out. It's not connected. Okay, how about S-Bus? Is S-Bus connected to anything? Aha, it is. That's disappointing. Why isn't RC? Now I have to go into the documentation. Unless 5 volts would be any one of these side pins. That should be USB. Yeah, and let's give any kind of diodes a chance to. How about telemetry? That should be. Yeah, the servos 5 volts shouldn't be. By the way, what is power? I thought power, that's probably 5 volts, right? Let's try this. What? No. Okay, pretty sure red is 5. That's 5 volts. This is the extreme side here. Hey, come here. Come on. So, no? Really? Oh, there we go. So SPI and I2C get their 5 volt bus. The GPS had another 5 volts, and I believe that pin, that one should be 5 volts. So let's try. This shouldn't connect. Oh, what? Which is the same. I thought I was trying this the other day and it wasn't. Okay, there we go. So 5 volts there. So now, yeah, the RC doesn't have any. It doesn't feed. I guess they figured when you had the RC PPM signal, the RC receiver would have been powered by, say, your ESC. Yeah, okay. Well, that's too bad. I guess, well, I mean, it's safe. It's fine for me. I don't have to worry. I'm using the S-Bus. That's the important bit, though. So S-Bus. Power, PWM. These are outputs. I need to note that S-Bus is consolidated with that. Someone call it that? It just says SB, but S-Bus. And I should make a note saying I don't have the receiver articulated on here, do I? RC receiver, I do. Okay. So S-Bus. Let's just make a note saying this is all in the 5 volt domain. And what is the domain called? I don't even remember what the Pixhawk calls the 5 volt domain for. Oh, what does it call it on the side? Just plus. Okay. I'd say 5 volt isolated. 5 volt isolated domain. And rotate. And I'm going to say that. So 1, 2, 3, 4, 5, 6, 7, 8, which goes here, and then S bus. That's correct. Okay. Yep, okay. And Spidey sense. Let's go check the printer. Looking over at it, it looks like it's fine. Let's get tunes going again. No tunes. Let's just do some more talking out loud trying to solve this. So I'm pretty sure that's correct. I need to make sure the ESC. Okay. The ESC has a 5-volt regulator on there. I need to decide then. So these are the two contestants for deciding what is going to power the servos and the receiver. The Pixhawk gets its power off of its dedicated power module, but if I'm going to have a 5-volt system failure, which of these... So the ESC, this is the Castle Creations ESC, 15 years old now, but I still trust it. But do I trust it for any number of servos? Versus Hobby King Special, whatever from China this thing was. This is definitely going to drive the Raspberry Pi. It has a switchable 2-amp output, which is going to be perfect for the Raspberry Pi. Actually, what did I measure for the Raspberry Pi for its current? Did I record it in this, or did I record it somewhere else? I think I put that on the Google Keep. Let's open up Google Keep and see if I wrote down the Raspberry Pi's current draw for its current... mixing up terms there. So Raspberry Pi Model 3. So I measured at the temperatures, but I didn't write down the current draw that I was seeing. Blast past me. Why didn't I record the current? Is it looking at me in the face on this sheet here? I'm just looking side to... Okay, I probably wrote it here. Raspberry Pi. Aha, I did write it here. 1.1 amps for 2 software-defined radio modules. So 1.1 amps, and this says it does 2 amps out on its switched output. That's fine. And then 3 amps, maximum up to 5 amps for its main. Output 5 volts or 6 volts, so you can allow for some voltage drop in the wires even. Input 7.4 up to 30. Dr. Mad Thrust. You know what? I'm just curious. I'm pretty sure I got you from Hobby King, but let's look up more about you. If I've got... Dr. Mad Thrust. Mm-hmm. Five amp HVBC, but this is mine. And I should register this with the FPV component info. Okay. Where's the appropriate point to register this? This is all very messy. Video switcher, video. This is basically turning into the main repository for all of my... so messy. I do miss OneNote. Having OneNote or other proper... I should try Evernote. There are other ways for me to keep track of things. But for the moment, this is basically turning into the main repo for... right here is probably fair. So what's the main name for this? It's ridiculous. Really? Yeah. So they've upped it. I guess it's basically self-documenting. There's nothing else on this that really needs status backorder. Yeah, that's really too bad. Well, I guess, did this replace it, or is this backordered to backorder? Yikes. Well, anyhow, yeah, contest between Castle Creations Phoenix 35, I believe. So, you know what I'm going to do? We are going to have this guy in power, which means this, the ESC, which hasn't been articulated yet. Or did I? I know I did the ESC somewhere. Where is that? The ESC is somewhere on here. Aha, there it is. Do I put the note here or here? I'm just going to have to put the note here, since that's the side where I'm going to have to note. Okay. So it's a note, because we are going to have the S-bus to receiver. So that means one of the PWM channels, I'm just going to plug in this guy to power the servos. Makes most sense. I could get away with plugging this guy into the receiver, but then I would have to travel all the way down the S-bus wire to power the servos. So yeah, I'm going to take this guy to servos. And let's try the whole bus entry thing. And name. 5 volts. Is that fair with my camel case convention that I'm doing? Let's make an entry. Oh man, I was hoping I could, can I rotate you? Sweet. Yes, best entry. Yes, best entry. Okay. Okay, very well, let's move that. There we go. And technically I can plug it into any one of the auxiliary channels as well. So I'm not quite capturing auxiliary out, I'm only capturing the main 8. By the way, auxiliary out, that is sponsored by the F427, I believe, which is the non-safe, This was originally developed for airplanes, so you could have your receiver pass through, where the receiver could completely bypass the flight computer. But now that you have multicopters, I'm not sure if current versions of the firmware. I need to. The point of this whole project was to get me back up to speed on the Pixhawk PX4 stuff. So here are servos to recipe. Let's actually imitate this. Slightly shorten. There we go. don't think I actually want to do that. I want to articulate that this is... I don't know, because that's pigtails. This is pigtails coming off of it, so yeah, that's fair. And this is also a pigtail. So that technically goes straight through. I've been too lazy to articulate grounds there, but you know. Switch bus B. Server 5 volts, and then I'm going to call this CPU 5 volts. Should I call it that? Is that fair to call it that? I have to do camel case with a lower... Oops. Must be 5 volts. I think that's a more fair stylistic. Okay. Servos. So that's technically bus C, RC switch bus C, which I should just call U bus C 5 volts. But then I should be calling bus B 12 volts. Or, what am I doing? I already called that plus 5 switch. What am I doing? I don't know what I'm doing there. Okay. T recipe. Okay. So the Raspberry Pi gets plus 5 volt switch, right? So plus 5 volt switch. Yep. Eventually, I'll get this to fit nice and pretty. Okay. I'll articulate that connector now. So we have a bunch of pins on the board. Okay. So we have servos, S-bus, which goes to the receiver. Where do I put the receiver? There we go, S-bus. Okay. So now, this is coming together. The UARTs, those have to go to Slim 1 and Slim 2. By the way, what were those UARTs expecting anyway? Are they 3.3 volts, and are they compatible with Raspberry Pi 3.3? So I'm pretty sure telemetry is 3.3 volts on the Raspberry Pi. Let's go find out. And those tabs are probably still up somewhere in my pile of tabs. Aha! There we go. No, that's not what I wanted to pan out. No. No. Was this it? Okay. So tell me about the voltages. Plus 3. Okay. So these are all plus 3.3, even though it powers it with 5. Okay. So now the Raspberry Pi, I thought I had the Raspberry Pi. No. Okay. Raspberry Pi pins. Just tell me the pinout and tell me what the voltages are. And I think I like this one best, but it's not going to tell me the voltages that the UARTs want. Okay, so GPIO 14, 18. Can you please tell me what the voltages are? Hey, check that out! That's exactly what I want, actually. Ha! Okay, that's nice to know. Where is this from anyway? ResearchGate. Download scientific diagram. Yeah, this is very nice. I'm basically playing catch-up for the last 6 years. Mostly ignored the Raspberry Pi Pixhawk stuff that people were doing because I was basically in airplane design mode. So, I mean, if that says you can make the direct connection, awesome. I guess this means the Raspberry Pi 3.3, since there are multiple references here showing people connecting the Pixhawk proper. Yeah, Raspberry Pi Model 3B, and yeah, check that out. And they're all going to telemetry 2. So all of these examples are like, go to telemetry 2, telemetry 2, telemetry 2. I guess it's settled then, telemetry 2. However, I'm using the MMOSD as well, which, what's this? Let's go back. Here. Yeah, there's some MMOSD, which is going to connect to... Let's go here, because this is going to be a guide, and we want the Raspberry Pi connection. Companion computer, where would that be? Companion computers, there we go. And overview, see companion computers. Raspberry. And MavLink router. Okay. Testing the connection, math proxy. This is all stuff that I'd very much wanted to do while at work. Yeah. Okay. So this isn't... whatever. We've got this, and I'll just go back another step here, which, oh, this is from GitHub, Easy Wi-Fi Broadcast, ooh, which is another one I wanted to do. This is by Bernard, whatever's, Benevi, I think was the rough acronym. Okay, so it still is up. What is Panout XYZ? This is a website I probably wish I'd known about forever. Or no, it's only Raspberry Pi specific. Okay. Ooh, wait a second. No, that's... JTAG. Oh, this is basically Raspberry Pi centric. Okay. What does Raspberry Pi do for ITC? And SPI. Okay. JTAG. Okay. Nice to know. So telemetry 2. Telem 2. What does MMOSD get? Because, they have to... What was telemetry 1 and telemetry 2? I should remember this. Telem 1 is for your RFD 900 type radio. let's do that, and Navlink serial. I should call this OSD serial. And then yeah, let's rename you. Rename, come on. Minimum OSD. OSD serial, lowercase, but I should be doing, just going to do that. Minimum OSD serial. Okay, copy because I'm too lazy to do that. Okay, so that is going to, minimum OSD, where did I put you? That one is actually explicit 0.1 inch spaced header pins because it was designed to work with the FTDI pinout. But the FTDI adapter will then plug into this guy just fine. So telemetry 2 is going to go here to our companion computer. Which will be a second header pin. I'm going to have cozied right up to this one. So there's going to be two headers. There's going to be the power header, which is the Dr. Mad thrust thing, which I'm going to have to cut. And this is really unusual. We're going to have to get a male-to-male servo cable, and that will have to just plug into this. It's already nicely, lovely, very lovely connection here, and I don't want to snip it. Yeah, ground. I still need to check for ground loops, but I will. I still wonder if ground loops are just a myth as far as hooking up machinery inside or close proximity to each other. It's long-range objects. Okay. I'm going to call you Raspberry Pi serial, or just RASP is the common shortening of that. So RASP serial, and can I rotate? Nope. So I'm sort of committed. What did I just do? F1? Oops. Okay. Okay, fine. Let's do this. Spidey sense is going off with the 3D printer. I want to make sure it's not exploding. But, okay. Let's copy and paste. And bus goes to here. There we go. So this will be some kind of a header connector as well. I'm going to have to find an FTDI. Oh dear, the FTDI won't connect to it, will it? I'm going to have to manually, I'm going to have to craft this. This is going to require crafting. And it's going to require me to chop up or find a formerly Mavlink to DF13 or whatever those high-rose connectors are called on the, whatever these are called here. Anyhow, Raspberry serial. That gets telemetry 2. Okay. So it's all coming together now. So we've already finished this harness. Well done here. Other little small things, like where's the placement of the switch going to go on the sailplane? Where am I going to put this? Because when I go to throw the sailplane, or if I have to go quickly turn it on and off to arm it, you have the switch. Spidey sense for 3D printer. Let's go see what's going on. kind of ugly. Oh well. It might have made more sense to have actually chopped it in half and to have constructed it as two different. You know, could I have done that? It's totally possible to chop this thing in half. Get rid of the supports. So with no support, technically, I think when I really do go to print this in the final production, I might want to just cut it straight down the middle, and then I'll have two slabs be printed. So that way the grain direction will be nicely aligned with the airflow. But that's... No, this is the way to print it. Even though, yeah, this really is the right way to print it, because for all of the curves, if I split it in half, then the layer direction would be this way, and you'd get plateauing, or what do you call that stair-stepping thing? You'd have really obvious stair-stepping, whereas with this way printed, you don't get much stair-stepping. I'm propagating all of the really fine, high bandwidth geometry to this axis. And then the dimension that has the lowest bandwidth is what you want to print up and down. So the lowest amount of information in that axis. So that way it's, So yeah, where was I? Cut this in half, and then you could totally print both halves. I'll get to this later. So do I have this in agreement then? Video max select with its 5 volts. And that 5 volts is going to be the domain for, let's see, max select. So let's put it back in. So because they're the same name, it's inferred. This is such a mess. And if this were Altium, it'd be an even bigger mess, because Altium had all sorts of weird rules. And KiCad, and neither of them, Altium and KiCad, are not what you draw harnesses in. You draw harnesses in, believe it or not, Microsoft Visio, or you would use Capital or some other proper system. And those are an atrocious mess that also cost a huge amount. So whatever catches the geometry. Just quickly running around here. So that's going to make a direct connection using its native pigtail, male-to-male servo header pigtail thing. And that is going to be handcrafted to connect to a Servo 3 pin. And this will allow for quick prototyping and debugging of equipment in the field by being able to plug things in and out. But this, this is the problem. I need to figure out how. What if I just do this? This is. I should slap myself on the hands. Bad engineer. Bad engineer. No, don't do it. But I'm gonna do it. What would happen if I take one mux? So this is basically saying I'm internally, for these two muxes being mated next to each other on the same substrate board, I'm basically going to be connecting them that way and removing the external connection there. Can I, should I do this? Yeah, you only have 3 devices and 2 outputs. You really could just take one mux. Me, I'm going crazy. Dear listener, forget. Where was I? Yeah, you could totally desolder. You're going to have to decase the other one. And then totally desolder. How do you do that, though? Can you smack them together? No, you can't do that. They're going to have to be side by side, but then you have a hidden side, which has to be... This is very stovepiped, very one-off-ish. If I were to do this the most natively correct way, well, because you're splitting there, you have to have handcrafting here. You'd have to handcraft harnesses on the outside. Or you avoid handcrafting harnesses on the outside by making yours Frankenstein on the inside. And then, do I preserve the video outputs? Yes, but those aren't going to be connecting to a harness. Instead, they are going to be hand soldered to... Where did the other proto board go? Where did I put that? There it is. So this is more like it. I could saw this in half, or as much of this as I need. And this is what's going to contain and have hot glued down. And also, is this aligned to the grid? It's barely aligned to the grid, and I need a bigger proto board. This is not... And this is what I would have used this if I were doing the video distribution amp, but now I need just regular raw. Where do I have a much larger raw board like this for an arbitrary size? I need to go to Micro Center today. So let's add to that. The Micro Center list for today. 4 by 6 inch prototyping board. Okay. So yeah, let's go there this afternoon. By the way, let's take a look at the weather radar. Instead of pulling out the phone, let's just go here. Weather. Oh, it's very bikeable right now. Wunder map. Oh, that's interesting. I want to go back. They actually added coronavirus to the output. Hey, come back. Fine. Go, go, go. There we go. Confirmed cases, deceased. Dang. Yeah, where was I? Weather stations, close hidden ad that's trying to push through, I want radar. And let's get that up to, I think 10x is my favorite speed. Let's see. I might want to just cut the stream here quick if this is on its way to hit sooner than later. Come on, bud. I wonder if this is going to be this way for like decades. You're always going to have super slow radar that just doesn't render very well online. Come on. Come on. You slow poke in the eye. Come on. Render. So at the moment there's no risk of rain and it's nice and warm, so I should totally be able to go biking as soon as I'm at a stopping point here. I'll put that at between, well, 45 minutes from now would be perfect. And 45 minutes in terms of this time, since this goes back an hour. I don't see anything hitting a 45 minutes from now. Okay, perfect. Okay. 2013. One day I will push many amazing things to DIY drones. Okay. Anyhow. So I've got that articulated. So the 5 volts here has to go to the microphone here. That's where I was about an hour ago. I have to make up my mind what I'm going to do here. So that is that it? Nope, I have one more. Okay. Could I... So I'm basically doing brain surgery on both of them. One of them is going to be the main output, the main presenter. And then its camera output is going to be intact, but then... Okay. Need more room. Need more space. Okay. Yeah, okay, fine. Let's do this. No. Right. There. Okay, now I have room. Grab you. Seems to be behaving correctly. So I can get rid of that. So I basically remove the pin headers off of one of these. Did I just accidentally remove that? What did I do? Is that correct? 3 to 2. Yeah, that's correct. Okay. So I'll be custom made, and I'll go to a 3-pin header, which will connect here and here and here. 3-pin servo, which that VCC okay, I have to condense this. This is really... I have to condense this because there's a lot of information I have to articulate, and I'll have to make it look nicer later. So ground has to be passed as well. Okay, so I have video and ground being passed. It doesn't matter whichever ground it is, it's just ground. Actually, the better way to articulate that is to say ground here. There we go. VCC, which video max out. So I won't even be having this max encounter at 12 volts, and 12 volts is only going to be injected on this max. Basically, what this comes down to is it's a mux pushing for the primary, the left wing. I guess this begs the question, so if that mux here, and then that's the backup system, So the tail, I really should switch that. I really should be having the mux that sponsors the tail should be the one that's the most inline critical path. This one pushing to the long range transmitter. Sound. So how am I actually going to handcraft this on the board? VCC is coming from bus A versus bus B. Now that I've made up my mind what I'm going to do with the powering things, well, I guess bus A and bus B still persist. It's just that bus A is on indefinitely, right? What was bus A supposed to connect to? Bus A primary 5.8 gigahertz transmitter. But that's not correct because this bus A is powering both of them. This, if I connect VCC here, VCC, which goes to the tail, and bus A, VCC, which goes to minimum OSD. Oh, okay. Because the 12 volts here gets bus B. Okay. And that is all hand soldered. It's a pigtail of some kind. So I'm going to have a pigtail with a Molex on the end, pigtail with another Molex on the end, so this is going to connect directly inside the fuselage instead of this one, which will be longer, free hanging, so it can go up through to the wing when I connect wings. And this was going to be a connector. Or do I want... This is a good question. Am I going to have a connection that's a free hanging connection for this, or is it going to be a connection based on a board? This is going to be a free hanging connection, probably. Yeah, let's do a free hanging connection. So that means, and the way I'm articulating what is just soldered directly to the board is by doing that. It's gross. It's the only way for me to force the dot. You can't just place a dot. If you place a dot anywhere in KiCad, but then you quickly do something else and you place a wire somewhere else, the dot disappears as soon as you've completed the wire anywhere else. So there's no way for me to just force a dot to make a note that's a discontinuity of some kind. So let's grab these, and say that it is on some kind of a connector. So let's see here. The microphone gets ground. I'll worry about that later. But the 5 volts should be coming from here. Do I want to explicitly run a wire out that, or do I just say it's plus 5 volts, and I just remember that it's connecting across those two inside of this entire domain? Minimum OSD, does it have... So it passes along 12 volts, and I think it needs 12 volts as well for the minimum OSD to be active. And yeah, it really makes the most sense. Well, yeah, that's bus A and bus B. I've removed that, or abstracted that, so I can still make up my mind later if I want to have... Well, and by the way, I did make up my mind. RC switch bus A. Wait a second, but am I reusing the name bus A or bus B? Bus A, but hardwired. And then let's just follow the same. Let's make sure that's correct. There we go. And Spidey sense is going off in terms of 3D printer exploding and making a rat's nest. I should go run over and check. By the way, stack discharger wicks. The idea behind this is to have sharp points along near the wingtips or the tail, because I don't know if this has really been studied in the small UAV world, but I would bet that you do pick up static. There is some amount of static buildup on small airplanes, and I wonder especially when with my long-range rig that's going to be flying for an hour, hour and a half. I hope to break my distance and time records with this thing. Yeah, how is it going to dissipate charge in the air? Especially it's a big foam airplane. So what does that do when you have a foam airplane with metal inlaid in it? How does it build up charge? What is the nature of that? You know, you see PWM. Switch C. Okay. So that's how the Raspberry Pi gets switched. Plus 5 volts. This plus 5 volts name, if I were to be really strongly typed here or very rigorous, I should not have this plus 5V and this plus 5V. They should not be the same name. Nor should that or that. They all need to be... Okay. They should be named differently. Anyhow. Where was I? So I'm basically crafting this. Again, I have to quickly justify or lawyer it myself why I have to do all of this in KiCad in the first place. It's because if you just blindly go in and think you're going to handcraft all of this, you're going to, as I've already discovered, make mistakes. And then you have to chop off large connectors and you have to redo things. And that prior mistake that was documented in, what, FPV stream 5 or 6 or 7 was basically, I didn't even measure how the cables would fit inside the body. And I'd assumed the cables would just fit inside of the body and that somehow everything would fit. But yeah, it's so tight in there with the autopilot and everything, it just wasn't going to be. And I like this. This is way simpler, more elegant, somewhat difficult. This is not long enough. This needs to be much, much longer to be able to reach out to connect to a wing that's being placed close by. So this may, in the future, have to be redone. Super annoying. Both of these will have to be lengthened substantially, which thankfully for servo cord, I'll just snip, but then it's going to require 1, 2, 3, 4 sets of splices and joints. And it's not going to be, anytime you interrupt a wire, you're just adding another point of failure. Okay, 3D printer, Spidey sense. So I'm going to allow the 3D printer to finish, but it is really ugly. I'm getting amazing amounts of wavy waffling in the part. Okay. So we're still live, 3 hours and 30 minutes in. So it is finished then. I've got a plan. Mux out there. Yeah, I just want to switch which mux is going to be the predominant or dominant one. So the dominant mux, the one that we're actually switching things into, and then hot gluing down those headers. So it's a semi-permanent installation that can be debugged in the field potentially. And leaves the option for switching, but I would be permanently, I would make this a permanent thing here. And I guess quick, almost math lesson here. Is there any way is this always symmetric? I guess is what I'm getting at. You select 1, 2, 3, 1, 2, 3. It doesn't roll. You can never have 3 cross to 1. It's 3, 2, 1, 1, 2, 3, 3, 2, 1, 1, 2, 3. You can never have 3 directly jump to 1 without passing through 2. So is that for 3 inputs and such. Yeah, I think basically, yeah, you're hardwiring this is not forcing me to, because I'm able to switch primary cam with tail cam with Raspberry Pi console, because these can be switched to whatever. So I'm not by hardwiring these here, I'm not forcing any kind of behavior set that I can't circumvent or modify through these selections. That's my intuition. It's not worth going through the math. I don't think well, I'd like to learn the proper math to formally prove that. But no, I'm not gonna, other than my intuition and whatever, it's not worth, is it worth the amount of work to prove that anyway? What was I? So now I think I'm ready to do this. Let us, here and here. Okay, so it's going to do 5 volts here. Oh, just C for copy. So 5 volts. This guy has 5 volts coming from it, so let's do serial. So his 5 volt supply doesn't ever interact with the 5 volts that does the mic. Since this is basically a PCB, let's articulate some capacitors. I'm going to put down capacitors and probably, do I have any board mount inductors? Otherwise, any inductors are going to be mounted on the harness. So was it C for capacitor, or was it D for device? I believe it's D for device, C for unpolarized capacitor. And yeah, let's just plop down a few capacitors, and I can plop down a second one, or I could have just done C. So we have capacitors for debouncing. I have 75 ohm resistors and 400 ohm resistors, but those are not going to be used since I'm not doing the beta distribution amplifier. Rest in peace. Where did I put the chokes? I thought I had that. Looking. Where did I put the choke? By the way, save just in case it explodes. Where did I put the choke? I had a choke symbol here somewhere. Where did I put you? What? Oh, there they are. That's where I put the chokes. So the inline chokes here, I think that captures it well enough. Do I have to repeat that here, showing that the chokes, there are actually chokes wrapped around right about here? Actually, the choke is wrapped around here and here. You know, I might as well articulate that. And I think I'll do that as a purple line. I mean, I only have one flavor of comment anyway, but let's just, should I at least duplicate the symbol? This is just to represent that, hey, you choked it, Steve. No, let's just do this. Choke. And that's fair enough. So, choke, pedo, and the, yeah, let's show where all these chokes are actually mounted. So in this case, the choke is right there, as I've shown, just on the opposite side of the bundle of joints. So choke there. And then I do have a choke mounted right next to the VTX side. It's basically right there over the shielding. Okay, so that's where I have a choke. So much information. the chokes here, and then where am I going to mount a choke? By the way, that thing has a choke on it. So its choke is change servos, and it has a choke. I might as well just record that. Copy here. Doesn't really articulate it very well, but so that already came with a choke mounted on it, which is this guy. You already got mounted address, has the choke right there on the connector here, so that will get to the servos. And this is the connector from the receiver. Does it power the receiver? Let's find out. I didn't expect it to. I sort of hope it doesn't. Otherwise, that's let's see here. So I'm just going to go for the connectors themselves proper. So here's one, and then here's the other. Okay, so there's no connection. Just to verify, ground does connect. I wonder, can I tell from looking at this if there's even... It's nice, that actually has a nice little metal shield on there. Anyhow, that is another headache for this entire project, is I have to properly shield, and I mentioned that about 3 hours ago, I have to properly shield everything. 5 volts and 6 volts, that needs to be hot glued down. Having a jumper come loose like that would be a disaster. I'm happy with 5 volts. I don't think I'm going to have the harness being so lossy that I have to pump 6 volts. And do I really trust this device? This is going to power all the servos, the Raspberry Pi, and basically the receiver. If this thing dies, the entire airplane goes down. The the Pixhawk would still be alive the whole way down, though, as would be the camera system. So at least I would have video footage and autopilot telemetry and logs saved up until the point of impact. On the flip side of that, if I ever had the Pixhawk power system die, that would crash the on-screen display. So Minimalist D, I actually don't know what this thing behaves like when it's depowered. I think it just passes through. Pretty sure it passes through, because it uses that OSD chip, which I think is what tampers with the path, and they would have that be fail-safe. So you would have your on-screen display would die, but otherwise the companion computer in here, it doesn't have a passive way of forwarding servo outputs. So yeah, if the autopilot had its 5-volt system die, then your airplane is going down. And yeah, I would lose motor control too. But yeah, back to this, which I was about to articulate before I got into this tangent. Whatever your receiver connections are, while the Dr. Mad Thrust would be alive, I might have some servo controls on the way down. Say, for example, if I gave flaps not to the autopilot, but flaps were given to the receiver and done with radio mixing, then I would have some directional control. The elevator has to go to the autopilot, though, and there's no split elevator system where I could have like 2 servos on each side of the elevator. This isn't like Zipline. I look at what Zipline does, and it's really cool what they're doing, and I guess it is for any kind of safety critical flight service, it makes sense to actually have 2 separate servos and just not even try to solve the issues of having one servo with multiple inputs. Just have 2 servos, 1 servo for each system. And then you just have to override the aerodynamics of one being frozen with the other one, hopefully. So I should articulate that. The last minute and a half of going over redundancies and what happens. How do I articulate all of this? Maybe just text, just quickly. If that fails. Now, if 12 volts, if bus B fails, we're coming up 20 minutes until I need to go to the Micro Center to buy black filament and proto board. You know, it's silly. I should have proto board. But I don't have it in here, and I mean I do. But it's the same thing, basically. Smaller form factor, but it still is basically. And I've got this, and then I've got unperforated and raw copper board, which I use for making anything that uses power, but okay. Let's put you away. So if PIXOC 5-volt fails, and this can be articulated later. What were the other things that could fail? Let's so bus A, we are going to copy this at least. Don't want to destroy information, but you know, let's just say you're just bus A. Bus A, which is the essential bus. There's no switching. And that's that. Bus B and bus C. So total of. Did I actually articulate that? So let's articulate bus B, bus C, and video max selection. Yeah, so I'm basically going off of memory. By the way, servo 5 volts, 5-volt isolated domain. Let's actually move all of this. I need to give myself a there we go. I want to grab you too. So yeah, what are you called? So basically 8 down to 1 and 6, aux 6 is what I will call you. 6. There we go. So servo 5 volts can go to somewhere else along whatever aux. Actually, let's just call you aux n, lowercase n for whatever number. So that way, that's just saying any one of the auxiliaries is going to have that plugged in. This is 1 through 8 are the pure and true PWMs from the STM32F100. Flap right, left, elevator, PWM, removing the 5-volt pin and the rudder. So, do I really want to give the autopilot that much freedom? The entire flight control set, I'm at the complete mercy of the autopilot. Well, yeah, if you're giving the autopilot the throttle, and the autopilot crashes while you're in the glider, it's not a big deal. But I mean, the ailerons, does the autopilot really need control over, not ailerons, but the flaps rather. Flap left and flap right. By the way, I'm not entirely sure if 6 and 7 or if it's, I don't know the exact arrangement. So that's B and C. Yeah. Let's just put down some notes. So, aileron, roll, rather, the roll stick, hitch, yaw. Okay. Pilot mode. RTH probably, or something like that. I'm running out of switches. And, well, here's the 2 notional receivers. So, 1, 2, 7, 8. And then, yeah, the Dragon Link version 2.1 or 2.7, 2. I can't tell what that is. I know that, so 8, 9, 10, 11, 12. And then RSSI, I think, or PWM, one of these. Anyhow, as far as, and actually let's articulate this by having a controller assignments. And as usual, my one flavor. Roll, pitch, throttle, yaw, mode select, video max selection. I also have to have the OSD. There's the OSD switch. Or rather, the OSD was sensitive to one of the RC channels being up or not. So autopilot mode select. What's I got here on my phone? Okay. So if I remember correctly, the OSD control, let's call it out. OSD, there we go. Let's actually, do I have the old controller up here? I do. So, this is what I used. Man, I have a lot of channels. So, what did I do for OSD? I think that was for OSD. I don't have any momentaries on this guy. But that was for flaps control. There's so many channels. This is insane. Okay. I'm forgetting flaps control. Okay. Flap condition. Yeah, flaps condition. Flaps/spoilers on this aircraft. And then there was also a pan tilt as well. This is insane. Oh, man. Okay, this needs to be split off to its own table. And I need to make a channel 1, channel 2, channel 3, channel 4, CH1. This is going to get really tedious. Okay, so these can go where they're supposed to, but this listing here, alrighty. You know what, I actually had this. Let me pull it up. So let's go through my photos. This is actually 4.5, almost 5 years old, maybe. Let's go to the whiteboard that I refused to erase and is still unerased. Took a picture of it a few weeks ago when I was in the middle of my panic packing. Where'd it go? Where did I put it? Google Photos, you're missing photos. Wow, okay, I have to dig back further in my history. Far back. Going way back. I'm thankful for good coworkers. And I'm not finding. Where did I put it? Aha, there we go. There's a panoramic view of my room. So this is where I live. And if I can kindly go back. How do I zoom in? Aha, there we go. This is the listing I wanted. And it's blurry, seriously. Okay. Okay, I give up. I can't find anything. I thought I took a picture of that. I was so diligent in taking a picture of that board to make sure it wasn't going to accidentally be erased. Let's go find another picture of that. There we go. That. So I did aileron, elevator, throttle, rudder, flaps, crow, what? Your service. Just view image. Why can't I just view image? Okay. So according to that, rudder, flaps, crow. Wait, what? Oh no. Max OSD pan. Autopilot 2. What is that? Lights. Yeah. That control. Flaps condition. Yeah, 2 autopilot channels makes sense. Unless I just do 1. This is already so fat and bloated. Because I have to have camera pan and camera tilt. Let's do camera pan. Because, yeah, there's a lot of controls. So the video controls, the autopilot controls for autopilot behavior, the your vehicle controls. And I'm missing one, I know it. Yeah, the lights and the, yeah. Man, what a mess. MOSD control. Might as well put that right there on that. And then I really didn't think this through, did I? How many controls I'm going to have? By the way, what's number 3? Okay, bear. Okay. What are we coming up on time? And me going off to... Okay. Alrighty, we are coming up on time. I'm going to cut it off at 4 hours. But, yeah, flight controls. I could probably get rid of this one. Video max select, and then I have basically 2 RC switches. 2 controls for the Raspberry Pi. Why do I have to reboot the Raspberry Pi? I don't know. Okay. Switch bus B. I don't know why I do S. There we go. Switch bus B. C. Again, bus B has lights, and if I so feel to do so, I could have bus A as well. So how many total is this? And also let's quickly go through how many channels have to be transmitted. I can do up to 16 channels with FR Sky, and Dragon Link I think goes up to 12, and I'm going to be going to 12 for sure. 6, 7, 8, 9, 10. I guess this can be split to things that are like camera pan and tilt. That requires flaps condition, some things are just switched. So these things are merely switched, but camera pan and tilt should enjoy the same level of granularity. And flaps, that can be an analog condition as well. That doesn't just have to be 3-position switch, that could be a knob. So flaps condition. Yeah, the rest of these are just on-offs. The rest of these are just on or off. Okay. And I just hit the 4-hour mark, but I'm going to go slightly over. And channel 12. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to get rid of the RTH, and now it fits in 12 channels. Did I miss something? Think through this. Roll, pitch, throttle, and yaw. Either on elevator, throttle, rudder, basically. Flaps condition into the autopilot, which hopefully does mixing nicely. Camera pan and tilt is going to be handled by the autopilot as well. Did I not? I didn't even have that registered up here, did I? That's going to have to be on the auxiliary bus, isn't it? So, yeah, camera pan and tilt is going to be handled as pass-throughs from the Pixhawk. Because there's no way pan and tilt are going to be able to go on maybe channel 7 and 8. 6, 7, and 8. I almost feel like I should just do that. Let's commit to 14. I'm going to commit to 14 channels. Autopilot mode select is going to be 3-position switch. RTH though, 3-position switch, could be 3-position switch, or rather it's a momentary 1 position, and then bus B and C. Yeah, the first 8 channels are going to be the highest priority. In, I think FR Sky and Dragon Link, they assign 1 through 8 have the highest graduations, number of graduations there, and then 9, 10, 11, and 12, those 4. Do I really need to switch the Raspberry Pi on and off? Could I just put everything on that bus? Could I have... No, because they're different. This one is switched through there. You know, I have at least 2 switched buses. Okay. I just feel like mode select, 3-position switch. You can put on potentiometer and do 5 modes, but it doesn't have to be high bandwidth. RTH is just a switch. Yeah, let's just get rid of that. And then, yeah, 4 switched. So basically 8 high bandwidth analogs and then 4 lower duty cycle, because video switching is low priority for changing how the OSD behaves and then switching things on and off. So this is the odd one out. Pan and tilt. Okay. And in terms of fail-safe, how do I want these to fail-safe? I'll probably have all of those go neutral, low, neutral, neutral, straight ahead, return to home. So the autopilot mode select will do that. I don't need to have a second channel when this one will be sufficient. And then the video will fail-safe to primary flight camera, minimize the full IFR display with GPS coordinates, and I'd have the Raspberry Pi switched off in the fail-safe condition, and bus B for the long-range transmitter would be fail-safe on, I believe. Why would I do that? Because the Raspberry Pi is an experiment, essentially, and the data it provides me is only if I'm in the loop. But if the airplane is not in the loop, then the data the Raspberry Pi is creating is not useful. Unless I really wanted to have the autopilot try to avoid traffic in the area, but that's such a low priority and so minuscule. I'd have to have 20 to maybe 40 close encounters before it would make sense to have the return to home also be aware of local traffic and avoid colliding with it. I would have to have 20 to 40 close encounters with airplanes over hundreds of FPV hours, I'm sure. Just having a close encounter. I have, for the old Sailplane and the 80 to 100 flights that I did with it, I never had more than 2 flights where I had maybe a medical helicopter fly over my base station while my Sailplane was 4 kilometers out. Nonetheless, when that happened, I would dive the plane towards the side of the mountain or whatever I was close to. I was always technically 400 feet above the ground or less, so. Alrighty, I have switch bus B, just bus A, non-switched. So in those, the cameras get hot, yes. 5 gigahertz transmitter gets hot, yes. But this gets hotter. And we want to always have the cameras on. Is there any reason you'd ever want to be able to reboot the cameras? By the way, 3D printer's done. Let's close off the stream with whatever that's done. And let's grab the screen. Well, it looks the part, except it's got severe warpage because it is hollow. It is completely hollow, but and severely malformed. But I didn't need that. I just needed something that would, the black filament, by the way, so I can print this black. I'm going to have a pan tilt mechanism mounted here on the top, in addition to the Raspberry Pi resting underneath inside. But pan tilt mechanism, traditionally you always paint the front of the cockpit black to avoid glare, and that's what I had in the last Sailplane, and that's what I'm going to do with this one. So I'm going to have, in terms of surface finish, so what if it's slightly draggy? Feathers are about the same texture as this, so I'm not going to worry about it too much. As to will this fit? It's going to require some work. I'm going to have to chew off. I'll leave that to the next stream, or at least I'll have pictures in the next stream of what happens after this. But first priority, let's go to Micro Center, and I'll basically have to put on the gas mask and go on the supply run, hopefully not to get or contact the virus. Let's go to Micro Center to buy parts. That's a mix of both 3D modeling using structure from motion, or 3D capture to be exact, along with manual measurements. And hopefully, it's just so warped. I'm so surprised this stuck to the print bed. It basically, I didn't even apply an ounce of force, and it just completely knocked off the build plate. Granted, the build plate had cooled down, but I'm surprised there's not more issues with this. And it's the PTG, which I hate, so I'm trying to get rid of it as fast as I can. So anyhow, let's call it quits for this web stream. A bit over 4 hours, but glad to have used this to focus myself. And dear viewer, I hope you enjoyed this. And until next time, bye.